Alright, so let's talk about the most stones removed with the same row or column. So you are given a 2D array, and then you have to either remove the stone if they have the same row or the same column. So this is a 2D plan. I'm going to just draw the diagram, and then these are all positive, right? So just give you a hint. So let me just quickly draw the uh, coordinate. So 0, 0 should be right here, right? 0, 1 should be right here. 1, 1, 0 should be right here, right? 1, 2 should be right here. And what else? 2, 1 should be right here, right? 2, 2 should be right here, right? So if you notice, this is pretty straightforward. Why? Like, there are how many stones? 6 stones. And based on this, right, there's a connection for sure. Like they are in the same row or same column, right? So basically, you can just what you can just draw the connection. So if you can connect every single stone with each other, and then you will know, okay, this is the connection, which is one connection in this 2D array. So you just subtract 1, which is 5. So which means you have to remove 5 stones. So if you don't believe it, right? All right, move on to the next one. So this is going to be 2D plane, 0, 1, 2, something like this, right? And this is 3, right? Okay, I'm going to just draw the diagram. So 0, 0, right? 0, 2, right? 1, 1 right here. 2, 0 right here, right? And then 2, 2. 2, 2 should be right here, right? So based on this, right? How many connection you have? You should have 2 connection. Why? This is one connection, right? This is one connection, and this is another connection itself. So you have 2 connection. So how many stone you have? 1, 2, 3, 4, 5. 5 minus 2 connection, which is what? 3. So the answer is 3. So how do you use the connection? So if you know the union fine, right? And then you will be able to understand really quickly. So I'm going to just write down my union fine, and then you will just follow along, because the union fine shouldn't be too difficult to write. And I'm going to explain why I'm doing this. So for the union file, I'm going to have an array, and basically I'm going to just point my stone for every stone to myself. So if I have 6 stone, right? So I'm going to point every single stone to myself. Then later on I will just update my current stone with another guy, right? With another stones. So I'm going to say in the array, I'm going to say notes, right? And I definitely need a size. I'm going to talk about the size later. So probably UF. I need to pass in the n, right? In n, and I'm going to just initialize my size equal to n, and also initialize my what in array, right? And then again, I need to point my every single uh, stone to myself, right? So it's going to be what? No, say I equal to I. Okay. So this is initialized, right? So for the union file, you need to union. So right, so it's probably void union, and you have to union 2 stone. I'm going to call A and B, right? So if you want to union A and B, then basically you need to find the current root for the current A and then current B, right? So you need a find function. So probably int find. I'm going to, because you have to return some number, right? So I'm going to say int, probably I would say root, right? So if you cannot find the parent of the root, it's not equal to is equal to a root, then you have to keep going up. This is like a tree, and then you want to keep finding who is your parent, and then if you can find it, then you need to update your node root to node a root. This is what, if you find your father, just for example, you need to find your grandfather, and then you need to update what? You need to update your root to your father. So you will keep finding your ancestor. And then this is going to be pretty much it, right? So you just have to return root. And then again, back to union. So we have to what? We have to find root A equal to find at A, right? Find A. and then root b equal to finite b, right? So I can just checking if the root a is not equal to root b, so which means they are at a different connection right now. So I need to connect together, right? So using the nodes at root a, I will say the root a to the root b. So I will connect the root a to the root b. So this is gonna be pretty much it, right? So but for the size, how do I know like the number of the connection they have, right? So if they connect together, right, I'm gonna decrement my size, right? This is gonna be pretty much it, because if you connect together, right, you don't need another extra node, right? So this is pretty much it. So at the end, just want to have a return value for the int. So public int size. I'm gonna just return size, right? So how do you actually write your main function? Remove stone. So you just have to check you check the first index with another first index, second index with another second index, and then so on, right? So I'm going to say int n equal to what? Stone.length, right? And then what else? And then initial my UF, union find, right? New UF, how many? N, right? You have n stone, right? And then for int I equal to 0, right? I less than n, I plus plus. And then my second value is going to be what? J equal to I plus 1. And then j less than n, j plus plus. So I need to traverse every single stone with another stones. So it's going to be what? N squared in this case. Now I need to pull out my stone 1. I'm going to say A equal to what? A equal to stone set I, and then B equal to stone set j. And again, this is an array, right? Stone is 2D array, so if I pull out one element, so it's going to be 1D array. Alright, so just making sure. And then I'm going to just say if the index A0 is equal to B0, right? Or the A1 is equal to B1, right? I can what? I can connect my UF union to what? I and J, right? So I don't care about the actual value in the stone. I'm care about the index, because the index is also represent the stones, right? So at the end, I just want to return. I just want to return the total stone minus the connection in the union find, right? So this will give you the solution. So let me run it, and then hopefully I don't make mistakes. And it looked like over time. All right, so I found out my mistakes. So which is right over here. You don't want your current root is equal to your parent. So you have to say, if they are not the same, right? You want to keep going up, and then you want to update your current node, and this is gonna be pretty much it, right? So back to here. So yeah, pass the test. So just making sure you know the union find. I mean, I made a typo right here. So you want to find out your current node in the union find with your parent, and then basically you just want to find the ancestor for sure. So this is going to be the explanation. So let's talk about time and space. This is going to be what? This is going to be time. This is all of n. This is all of n. So it's n squared. And in the union find, which is what? You basically use what? Log n, right? Basically. But I would just say log n. And then this is n squared times log n. And this might be shorter, but the worst case is going to be log n. And yeah, so let's talk about the space. This is space, this is space, this is space, and the space is going to be the number of stones depending on n. So this is all of n for the space, and then n squared log n for the time. And this is the solution. I'll see you next time. Bye.